Today we are starting our 8th lecture on automobile engineering, and today we are discussing what do you mean by the carburation. What is carburation and what is carburetor? This is our topic of discussion for today. So what do you mean by this carburation? Carburation is defined as a process of mixing of combustible fuel with a proper amount of air before it enters into the engine cylinder. As all of us know that during the suction stroke of the engine, as we know that there is a four strokes are there: suction, combustion, expansion, exhaust strokes are there. And during suction stroke, the air fuel mixture is delivered into the engine cylinder, and in the combustion stroke, this air fuel mixture is combust and spark is initiated and the air fuel mixture is burnt and expansion is taking place, the power output is produced, and then exhaust is taking place. Then the waste gases will be get expelled out. This is what happened inside the spark ignition engine for stroke engine. But in the case of a CI engine is concerned, only the air is delivered inside into the cylinder during the suction stroke, and fuel is injected by means of a fuel injector. And in SI engine, we are air and fuel mixture is introduced. That a proper mixing of the air and fuel is required for the proper operation of the carburetor, means the spark ignition engines. So here we are using a carburation system. So carburation means just for mixing the air and fuel in a required amount. The proper air fuel ratio is needed. The purpose of carburation is to provide an air fuel mixture in a required quantity and quality for the efficient operation of the engine. So different operating condition, as per the different operating condition, the different quantity and quality of the air fuel mixture is required. For example, if you are doing acceleration, more fuel is required because we need more power is required. So to more power means more fuel is to be merged. Then only we will generate more air power. And during the cold starting, sometimes it is very difficult to start the engine during the cold weather season, or if the engine, if you haven't used the vehicle for a 2 or more day for a week, it will be very difficult to start the engine. So what we will do? We will operate these choke valves, then the engine is started. So here the air fuel ratio is changing. So depending upon the condition that we are you operating, the different air fuel mixture is required, and the quantity and quality of the air fuel mixture will be changing. So the purpose of carburetor is to prepare an air fuel mixture and supply this air fuel mixture and depending upon the quantity and the quality as required by the engine. The correct air fuel ratio is important in performance of the spark ignition under various conditions. So here we will discuss various operating conditions, that is the idling and the cold starting and accelerating and cruising, etc. Okay, idling means just the engine is in a non-load condition and it is in throttle is fully closed and system that is engine is not engine is working but the vehicle is not moving. Okay, that is the on position. That is a no load and the throttle is full open position. That is what we call as the idle position, and this cold start as already discussed now. And accelerating means then we are, for example, if we are overtaking a vehicle, we need more, and we are pressing on the accelerator pedal, or we are giving an acceleration on the in our bike. The accelerator drum is rotated. So in such condition, more power is required. So more fuel is burnt. So different rich mixture is to be provided. Okay. The process of carburation not required in combustion ignition engine, that is a CI engine, or we can call it as a diesel engine. In this case, the fuel is directly injected into the compressed air in the cylinder at the end of the combustion stroke. I think these are things we are already discussed in your previous lecture, and also in starting of the lesson we have discussed these things. And now we are discussing what is the carburetor. So the device, till now we are discussing the carburation. What is carburation means just mixing of the air and fuel and preparing the required air fuel mixture. So the device which mix air and fuel, the required ratio is known as a carburetor. Okay, that is what we are shown here, and we will show the detailed diagrams or the working diagrams in the upcoming lectures. So my question is, where is the location of this carburetor in the vehicles? Normally, the carburetor is placed in between the intake manifold. The carburetor this is a carburetor, and the carburetor is placed in between this intake manifold and the fuel tank. So the fuel which is stored in the fuel tank is fed to the carburetor through the fuel lines, and the air that is coming into the system through a air filter and purifying the air, and after purifying the air is getting to this carburetor, and in this carburetor the fuel plus this air get mixed, and air fuel mixture, that is what we call as charge, and this charge is get into this intake manifold. From the intake manifold the inlet valve will remain open and it is acting into the engine cylinder. That is what is happening. Okay, that is what here shown here. Your carburetor, the fuel and air is mixed, and through the intake manifold and into the suction stroke the piston is moving from the top dead center to the bottom dead center, and this air fuel mixture is getting to the cylinder. Okay, then the cycle is completed, that is suction, compression, expansion, exhaust, and the work output is produced. So different types of air fuel mixtures in a carburation. So now we are discussing different air fuel mixtures. So here the schematic representation of the air fuel mixture. So here you can see a combustible range is shown here, and two lean mixture and two rich mixture. This classification is based on the amount of air and amount of fuel that is present in this mixture. Okay. So there are three types of mixtures. One is chemically correct mixture or stoichiometric mixture. We can call it stoichiometric, or is known as chemically correct. And second one is rich mixture, and third one is lean mixture. So let's have a look what all these things mean. Okay, first of all, okay, we know that normally an engine will work on a different load and different speed condition. Sometimes it will be at a partial load, part load, some it will be not full load, and the speed may also be vary depending upon condition. For example, if in a highways we may travel within a very high speeds, okay, and but in the case of a traffic, we won't travel with the high speed, and it depending upon the conditions of the road or the high range area, and depending upon area and the locations, the speed and the load and different conditions of the engine may be changed, and depending upon these conditions we need to transfer different air fuel ratios to the engine. The required air fuel mixture ratio vary according to this operating condition. So our operating condition is important. Based on that, the air fuel mixture ratio will be varied. The proper air fuel mixture is to be supplied to the engine cylinder for efficient working of the engine. If and only if the engine is supplied with this proper air fuel mixture, the engine in the system will work properly. Okay. According to the amount or mass ratio, the fuel and air get mixed in carburation. The mixture is classified into three, that is chemically correct, rich mixture, lean mixture, that already we explained. So what do you mean by this stoichiometric or chemically correct mixture? Stoichiometric mixture is a type of air fuel mixture in which the amount of air is just enough to complete the combustion of the fuel. So combustion means the burning of the fuel in the presence of air. So we know that the air is required for the burning. Combustion means the burning. So for the complete combustion, so always the combustion should be complete. So incomplete combustion is not favorable. Incomplete combustion means the amount of air is not sufficient to burn all, or we can say that the amount of oxygen available is not sufficient to burn all fuel molecules. So in order to burn all fuel molecules, we should supply the proper amount of air. So the amount of air molecules or the amount of air which is required to burn the fuel completely, that is what we call as a stoichiometric or the chemically correct. So it won't be any incomplete. So the complete combustion is taking place. So it's a chemically correct mixture. Okay. So you can write the chemical formula. For example, for methane is required, so CH4 is the methane, and we are burning it. So with then O2, then you can write down the chemical equation. Then how much carbon dioxide and water is produced, and balancing this equation. So it should be a complete reaction. There won't be any methane should be balanced there, or oxygen should be. So it should be completely converted. The complete burning means that all the hydrocarbon present in the fuel is getting converted to carbon dioxide and hydrogen. Water. So you know that all fuels are the hydrocarbons. For example, methane contains CH4. Okay. For C octane, that is C8H18, that is octane. If cetane is considered, C16H34. Okay. So all in this case, we are dealing with hydrocarbons. So this hydrocarbon should be completely converted to carbon dioxide and water. Then we can say that the combustion is complete. Otherwise, it will be an incomplete combustion. So, in order to be a combustion to be a complete, to be perfect, a stoichiometric mixture or the chemically correct mixture should be provided. The amount of air required is calculated from the chemical equation of burning of particular fuel. So you have to write down the chemical equation. Then only we can understand whether it's a combustion process is complete or incomplete. Okay. We are not supporting some such incomplete combustion. This is not favorable for the engine. Okay. It will result incomplete combustion may be result in the knocking and detonation, various engine problems are there, and it will be result in the environmental pollution also. This unburned hydrocarbons will be discarded to the atmosphere, and it will badly affect the atmosphere, creating the atmospheric pollution. Okay. So then what do you mean by this rich fuel mixture? This type of mixture contains the amount of air less than the amount of air present in the stoichiometric mixture. The air is less than the amount of air present in the stoichiometric mixture. So normally stoichiometric ratio, that is stoichiometric air fuel ratio, is about 50 is to 1. That is 15 parts of air is required to burn or to combust 1 unit of fuel. So 15 unit of air is required to burn 1 unit of fuel. That is a chemically correct mixture. So if the amount of air is reduced, that is what is telling here. The type of mixture contain the amount of air less than the amount of air present in the stoichiometric mixture. For example, if you consider that as 9 is to 1, that is 9 part of air is required to burn 1 part of fuel. So amount of air is reduced, and the amount of air reducing means the amount of fuel present is more. So it is called a rich mixture. During acceleration, we require more power output. So to produce more power output, more fuel is to be burnt. Okay. There is no adequate amount of air for the complete combustion of fuel. The mixture has excess fuel. And for example, if you answer as a 12 is to 1 is an rich mixture. And what do you mean by an air fuel, lean air fuel mixture? Lean means just opposite of the rich mixture. In this lean air fuel mixture, which has more air than the stoichiometric requirement. For example, you can say it is an 18 is to 1. When 18 part of air is required to burn 1 part of fuel. So more air is to be supplied. Normally in idling condition, we can use an lean mixture is enough. Okay. Not idling condition, we can say it is an cruising condition. That is a normal operating condition. Okay. More economic option. It is a more economic option. Lean air fuel mixture. It is a normal operating condition. But in the case of idling condition, we are using the rich mixture circuit. Okay. Because in order to keep the engine alive, more amount of fuel is to be supplied. And the throttle valve is almost completely closed and there is no load condition. And we are by using the idling jet, we are supplying the idling fuel, and more fuel is to be supplied. Air is very less. That is what you are using the rich mixture. So we will understand all these things while we are discussing the working of a simple carburetor. Okay, in the next lecture. So during the starting of the engine, during the acceleration or ideal condition, we are using the rich mixtures, and during the cruising condition, that is a normal operating condition, we are using the lean air fuel mixture, which is a more economic option. Okay. Normally, we are not using the chemically correct mixture is not used because even if it is chemically correct, we are slightly excess fuel is always employed. Okay. The lean mixture is more efficient than a stoichiometric mixture. The advantage of the lean mixture include less heat loss, less heat engine knocking, low throttling loss, and achieve higher compression ratios can be achieved in the case of lean air fuel mixture. Okay, something should be noted down. Then next we are discussing the factors that affecting the carburation. These are the factors which should be considered by designing the carburetor. That is engine speed, temperature of the incoming air, vaporization characteristic of the fuel, design of the carburetor. First one we are discussing the engine speed. We know that the modern engines are running at very high speed that reduces time for the carburation. So suction, combustion, expansion, exhaust stroke. These are all taking place very fastly. They're high speed. So there won't be enough time for the mixing of the air and fuel. Very minute, where milliseconds are available for this air fuel mixing. And then it should be transferred to the engine cylinder. Okay. For example, if you consider an engine which is running at a 3000 rpm, only 10 milliseconds are getting for this carburation, and within that time we have to mix the air fuel and the charges to be produced, then only and the system will work efficiently and effectively. Okay, in this scenario, in order to get high quality air fuel mixture, the velocity of air should be increased. Higher the velocity and more will be the pressure drop created, and how more fastly the fuel will be delivered, and the mixing of the air fuel mixture will be taking place, and charges produced. And here we are employing the eventual type arrangements. Okay, that we what we will eventually that we will be discussing in the upcoming sections. And next one is the temperature of the incoming air. So how the temperature affecting this carburation? So temperature and pressure play a major role in producing homogeneous air fuel mixture. High air temperature increases the vaporization of the fuel. We know that the air is delivered into the carburetor, and we are also delivering this fuel. Fuel means it is the fuel droplets are there. So we need to atomize, that is vaporize this fuel molecule, fuel droplets. So the fuel molecules should be and this air fuel mixture should be a proper mixing will be there only if the atomization is to be effective. For that, the temperature is raised. What will happen? High temperature increase the vaporization of the fuel. The rate of vaporization will be improved. By then, what is the easy method to increase this vaporization or can this temperature? How can we increase this temperature? That is by heating the intake manifold. But there is a temperature limit for that. Okay. The higher temperature of input air decreases the output power and volumetric efficiency. These factors should be taken into account while increasing this intake manifold temperature. And next one is a vaporization characteristic of the fuel. So the fuel should be easily volatile. Okay, the presence of highly volatile hydrocarbon in the fuel plays a big role in good quality carburation, especially at high engine speeds. If the fuel is less volatile, the atomization will be very small and proper mixing won't happen. As the engine speed is goes on high increasing, we should use more volatile hydrocarbon fuels. So new research should be there to find out more effective utilization of the new gen fuel should be there. Okay, so the easy volatile. So that fuels that vaporize easily at normal temperature give good carburation. And next one is the design of the carburetor. There are different types of carburetor based on the design. So carburetor must be designed for quality carburation in various operating conditions. As we already discussed, cruising, idling, and power operation, and cold starting operation, etc. Okay, so that's for today. For the next lesson onward, we are discussing the simple carburetor, how the simple carburetor is working. Okay, till that, thank you. Thank you for watching.